Hello again, you sick, twisted weather freaks. Welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and all-around evil scientist, DT from WxRisk, located here in Richmond, Virginia, the captain of chaos, the colonel of confusion, the commander of catastrophe. Time to talk about This Week in Weather. And of course, we have a lot of tropical activity finally to talk about, and rather what's been a difficult forecast wise, but semi boring summer. So let's get right to this. We're going to talk about Florence, TD number 7, Gordon, and then Helene, probably. All right. First, this is the slide image of this is a satellite picture from August 30th, and for Africa, and from the folks over the UCMET. And of course, that system there you see here is the actual Florence. And of course, you can see other systems embedded over in the intertropical convergence zone there along the equatorial portions of Africa. But I just wanted to show you that's what it looked like a few days ago. Then, of course, this came out and it showed, the chances initialized, I guess this was early Saturday morning, tropical storm force winds probabilities, and you can see for September 8th, which was I guess what 6 days away. But this was based upon, like I said, early Saturday morning, and you can see that it actually had Florence. I guess this is implied Florence here. This would be Helene here, right? Assuming Gordon develops in the Gulf of Mexico, so that would be Helene. Anyway, so you can see, but again, it looks like these systems are tracking in this sort of direction and probably have a recurve to north. And there was a lot of consensus forecasting that was going to be the case. Now, this was, of course, the early morning statement from the National Hurricane Center. This is obviously on this Sunday morning. This is Florence here, and this is the next system likely to develop and move into the Gulf of Mexico. This is now Tropical Depression number 7, and it's probably become Gordon in the next 12 hours, I would think, or something close to that. Of course, it is close to Cuba and moving into the Florida Straits, but other than that, it's in pretty good shape. And you can see this is the official track here from 5 p.m. From the Hurricane Center. You can see the track is unchanged. It's been that way. It's obviously going up in this direction, and you can see, and of course, it doesn't reach hurricane strength quite over the next 5 days. And there's Bermuda. So obviously, I guess the implication is it's going to do this or something like that. Of course, if you look at the upper air pattern, there's a whole reason to think that it's not going to do that. It might turn more to the west. We'll get to that in a bit. And this here is, of course, the Tropical Depression number 7, or probably Depression 7. You can see again, becomes a depression and then goes into the northern Gulf of Mexico and then Louisiana as an ordinary looking tropical storm. All right. So here at WxRisk, one of the things I like doing is I like thinking outside of the box. And of course, the problem is thinking outside of the box is you don't want to be so outlandish that you end up looking like a weirdo or a kook. So you have to walk that very careful, fine line between making a good, valid forecast and making a forecast which is too outlandish to be believed. So Saturday morning, I put out this on the Twitter account. It said, "Is Florence a threat to the East Coast of the U.S.?" Yes, it is. It's a threat, not a certainty, a threat. Okay, I chose my words carefully here. Now, I thought, many people were saying, yeah, it's going to go out to sea. It's going to go out to sea. Now, when I put this out, immediately I got a lot of crap from a lot of people, mostly weenies, who I like to think can play Joe Bastardi or Jim Cantori and run their own little weather service, but they don't really know their ass from a hole in the ground. And you can see that my argument here was that there was a widespread of possible solutions. These are all different possible tracks here of the European ensemble, its solution. So the mean, which is the dark blue in here, you can see what it's doing like that. And then the operational one is the black line, but you can see what it's doing. And of course, many of them are down in here. So I just am making the argument that there is some reason to think that it might not go out to sea. I didn't think that's a particularly controversial statement. I still don't think it's a controversial statement. If you think that statement is wrong, blow it out your ass. I'm sorry. That's a very reasonable statement to make, given that sort of spread. It just is. Now, why was I talking about that? Well, this is why. Yeah, this is the upper air pattern here. Now, again, this is from early Saturday morning. Saturday morning's European model. And again, this is the European ensemble. So let's take a look. We have to look at all the features of North America. This is a heat dome here, right? This whole feature in here. You see this pink area? This is the heat ridge. And this is the dome over the Mid-Atlantic. This is for September 5th. So it's going to get hot again in the Mid-Atlantic states, folks. I'm sorry, but it is. Now we have our ridge here. We have an upper low here, trough of the Pacific Northwest. And this teleconnects to that ridge. Now this is the system, I guess it would be maybe a number 7, tropical depression number 7, going underneath it. Or it might be, I could even make the argument it might be a Helene, but this obviously is some sort of tropical wave there as well. But the point here is a huge dome. You can see that over the Mid-Atlantic states. Now what happened is this. So my next statement was, again, is Florence a threat to the East Coast? This is Saturday morning. You can see what happens. The ridge, the dome, expands or pushes out into the northwest Atlantic Ocean. And this over here is where the models believe that Florence is going to be, right in this area, right in here. So as you can see, if it has not turned north by September 7th, and it still might, this ridge moves out into the Atlantic Ocean from here. It goes out in this direction, and it blocks it. So it forces Florence to turn to the left. That was my hypothesis or possibility I was looking at yesterday. And of course, some other people began to pick up on it. This is the great Alan Huffman from Raleigh Weather, and you can see this is his post from, I guess this was a Saturday afternoon. The European ensembles came out, and again, a significant spread here which exists. If you look at these red lines here, these very thin red lines, some of them are out to sea, some of them are to the north, and some of them are over here, headed towards the U.S. East Coast. It's a possibility. I don't think that's a controversial statement. Now let's take a look at the system right now. This is Florence this afternoon, this evening. You can see the western side of it's undergoing a little bit of a shear here. But you can see the overall track. It's definitely a tropical storm, not a particularly great one. And you can see the shear. You see the red lines in here? Let me make sure you can see the red lines here. Okay, you can see there's one here and there's the other one here. So it's getting some shear here on the western side of it. And it's not, that's why it's not particularly intensifying rapidly. Also, the water temperatures are not particularly warm. And it has a lot of dust ahead of it. This is all Sahara dust. I'll call it up so you can see it. This is all Sahara dust in here. So the hurricane is underneath the dust, and it has to punch through this before it can really intensify. So that's another, not a hurricane, excuse me, tropical storm Florence has to intensify before it has to get through that dust area. And that's a problem. You can see it also in the water vapor. Again, there's Florence, very nice. And then this here is the dust. You can see the dry area in here from going off Africa. So it's got to get it through that dust, and then it'll be in better shape. Now this is the spread from early, and again, this is the spread of all the models, and this is a very nice depiction of most of the models on the morning of September 1st. And you can see that again, the European models were way over here, and the Canadian was way over here, and the British and the American models, the AVN, the GFS, right here. 3 different possible scenarios, and this was Saturday morning. All right. Now, let's get into this. Why extended hurricane forecast tracks past day 4 or 5 are often wrong. Now, besides the usual reasons, the limitations of the models, the data gaps in the model grids, not having a lot of data points in the Atlantic Ocean, etc., etc., etc. The other problem is, all hurricane models suck after day 4 or 5, especially when the tropical cyclone begins to turn to the north, or begins to interact north of 25 north latitude. Once it gets up to the mid latitudes, it has real problems. Hurricane models are not made for that. Those are the jobs of global models. You can't have a hurricane model which can handle the mesoscale features of hurricanes and the wide scale global models. It just doesn't work that way. Many of the hurricane models are run off the wretched GFS grid, and that's a problem as well. Not all of them. The European extrapolation models are not, the British models are not, but a lot of the other models are, and that's a problem. Medium range forecasting has to be done all year round. Okay, if you're a hurricane forecast since November 30th and you stop looking at the medium range models, that means that come next May or June, your medium range skills, you don't know what's going on here, and that's a problem. You have to do this all the time. All the time, and you have to see above the actual models and the entire overall pattern here in North America in order to figure out what's going on. You have to see it all the time. That way you can figure out what's going to happen in day 4, day 5, day 6, day 8. This is really important. You have to do that. Otherwise, you're going to miss things. You simply cannot rely on hurricane models. Let me show you what I'm talking about. All right, this is the rainfall last 14 days in the Midwest. Why am I talking about the rainfall in the Midwest? Because this is an important part of the pattern. Yeah, if you don't know how wet and stormy the Midwest has been, you're going to miss what's going on in the Atlantic Ocean. Let me repeat that. If you don't understand and see how wet the Midwest has been and it's going to be over the next 7 days, you're going to miss what's going on in the Atlantic Ocean. It's just that simple. Now, look at the purple colors here, folks. These purple colors, look at this, 8, 9, 10, 11 inches of rain, all up in here. And the dark red, 3, 4 inches of rain. Look at this thing. This is flooding rains. If you're farming, if you're trading here, this is a lot of rain in Iowa, in southern Minnesota, Wisconsin, northern Missouri, places like that. And this is not good. This is a real problem. Now, why is this important? Here, this is the overall pattern on this Sunday afternoon. We have the ridge, as you can see, right in here. Here's the ridge. Here's the heat dome, as you can see that. And then we have the one trough coming in here, next piece of energy in here. These are going to be rainmakers for the Midwest. But what they're doing is they're keeping this in place. Okay, this is tropical depression number 7 down here. But as this dome gets bigger and stronger, it's going to ensure that flow can't go out to sea. You'll see that in a minute. Okay, here are the models for this afternoon. European, GFS. Now usually the GFS is always wetter than the European. Look how bloody wet it is in Iowa. It's got 12 inches of rain in the next 7 days. That's a lot of rain. Now look what happens. You know, the GFS, because the model resolution is not as great, always is wetter, but you can see what I'm talking about. Look at the sharp delineation here. Nothing in here. Nothing. But you see the GFS always has more rain in this area. It's much, you know, because it doesn't understand the dynamics of the ridge. The model resolution is just not as good. Now, it still has significant rain in Iowa up in this area, but you can see the plume coming up like this. And all these models have the plume, but look at this rain. This blue stuff is 5, 6 inches of rain. The dark red stuff is 8, 9 inches. Purple stuff is 8, 9 inches of rain. And you got 10 to 12 inches of rain in Iowa. This is devastating rain amounts. And it's going to do a lot of damage to the crop, the grains, if this is correct. This is really bad news. Now, the reason for this is important is because it doesn't change. Here's 48 hours, the upper left map here. Okay, Tuesday, September 4th. And there it is on day 7. It hasn't changed. The dome is weakened a little bit here, but you can see the ridge is still very strong right up in here. There's the next trough coming in this way. Here's the one there, September 4th, and there's our dome. Look at this monster dome over the Mid-Atlantic states. And here it is at, again, this is 96 hours. You can see the dome has not moved. You see, it's right there. Boom, it hasn't moved. Now, again, this is some sort of tropical system here, and it gets blocked, but you can see this gets blocked right away by the dome there. But overall, the point here is the dome is there. It's in Virginia. It moves out into the western Atlantic Ocean, and it doesn't go anyplace. Let me show you. This here's the European model, 192 hours. Same thing. There it is. Here. Now we'll clear this out, and here's the next one. So you can see it. Here it is right here. Same thing. That's Florence, right there. This is Florence. This may be Helene right here, as you can see. Now look at the ridge. The ridge extends way to the north. This is blocking Florence. It cannot do this. It cannot, if this is right. If this is right, so it has to turn this direction. If that's right. We don't know that yet. The European ensemble, there's the Bermuda High. This is a classic Bermuda High or a Western Atlantic Ridge. You can see it very strong up in this whole area. This whole feature right here. Let me get my marker out so you can see it. This is the Bermuda High, Western Atlantic Ridge. And that means whatever's coming up this way is not going out to sea. So it doesn't mean it's coming to the coast. It could pass between Bermuda and the coast, but it's not going out to sea. This is not. So I don't think so. All right, next we'll go here. Let me clear this out, and you can see this is day 9. There it is. This is our huge Bermuda High, a Western Atlantic Ridge, and the hurricane is trapped underneath it, being forced to the west. And look, another trough coming in. Another trough that remains in the Pacific Northwest and Northern Rockies. More shortwave, more rain from the Midwest. This system comes to the East Coast, and this whole system is keeping the ridge in place. So if you don't understand this, you're not going to see this. Just that simple. Okay. The ocean water temperatures you can see out there in the tropical Atlantic is still quite chilly. Florence is still out here, as you can see, in this whole area, so it's still quite cold. Now, once it gets, into this area here, it'll turn much more favorable. But right now, the cold water temperatures are not particularly conducive to anything happening. Now, another problem is that there is a possibility the system may weaken sometime by the end of the week. So again, this is the afternoon European here from this September 2nd. Notice what happens. The system kind of collapses. I guess this would be, yeah, September 7th. You can see it. Let me call it and mark up. Notice how weak it gets, 10:13. There's the next one, and this is probably Helene here. So this is what happens is there's some shear going through on in here and a few other problems, and it weakens. Maybe it's the dust here as well. Notice the gargantuan high in the Atlantic blocking it. This is not going out to sea. Not like that. That's not happening. And if this high comes down here, it's going to block it again. So, this is a pretty significant map. That high sitting in the middle Atlantic Ocean means this system, if it's alive, is Florence alive, is not going out to sea. Okay. And you can see this here on the European with more clarity. This is the day 9 European. The ridge is there. And now, excuse me, this is the GFS. Excuse me. Now let me show you why the GFS is a piece of crap here. What it's getting wrong. Look at the trough here. This is day 9. This is the 12Z GFS. Okay, Sunday today. There it is, day 9. Okay, valid September 11th. There's the trough. You see how deep it is? And because the trough is deep, it curves it out like that. Okay. Now let's take a look what the other models are doing. This is the GFS ensemble. Totally different. Let's go here. It's there, 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 there. There's no trough over the Northeast. There's no trough here. There's no crying in baseball. There's no trough here. That's not there. And as a result, the system is being forced. There's a ridge forced to the west, going around it. Big difference between that and that. And if we look at, sure enough, the European at day 9, it doesn't, again, here's the GFS, the trough, European, no trough. It's got the huge dome there. We've had heat. There's not going to be a trough in the Northeast, the Great Lakes, Mid-Atlantic, at day 9 or day 10. It's just not going to happen. It hasn't happened for weeks. We have this heat ridge over us. It's going to continue probably through September 20th. So if you don't know this, if you have been following the medium range models, you can think the GFS is viable. That's why you have to do medium range forecasting all the time. You have to. Otherwise, you're no good at it. It's like playing baseball, whatever. Okay. So here we go. There's the ridge right here. And there is Florence, as you can see it. This is Helene, and this is Florence. And it has to go around it. Now, I'm not trying to imply it's going to hit the East Coast. There are several variables, but it could get close. It could get close. And yes, it could hit. But we don't know that yet. All right. Here is the surface reflection of that. So that's the upper air map. There's the surface reflection. All right? Florence, Helene. And again, notice here, enormous high here, enormous high here. When this one goes away, this one comes down. It is blocked. That's what that's telling me. Good luck with that GFS thing. And there it is at day 10. The high is in the Western Atlantic Ocean, pushing it towards the coast. And here's the ridge. Not only do you have the dome, this big Bermuda high here, but you have a ridge here. These heights are going up. So you have another kind of semi-ridge here. I gotta tell you, it looks a little bit like Isabel, quite frankly. And then this is the pattern, very close to the coast. Now, I don't know if it's going to reach the coast. I'm not saying that. I'm just letting you know it's a possibility. Even the GFS is saying it. This is the 0Z, 6Z GFS, as you can see right here, valid Tuesday, September 11th. And look at the shift to the west. It's already further west, considerably so. Same time frame, exact same time frame on the GFS. GFS ensembles. Again, the 6Z, valid for September 11th, and the again, this is the 12Z. You can see the shift there as well. And here is the day 10 operational GFS. Again, you can see it's really far out there. I think this is the GFS F3, and I think it's, as you can see, it's pretty far out there. But this was the early morning, excuse me, this is the 0Z early morning GFS, and you can see how far to the east it was. And you can see the shift here. Look at the difference. This is 18Z. 0Z, 18Z. 0Z, 18Z. That's a huge shift, boys and girls. That's telling me the European's right. That's what that's telling me. Look at the shift in the models. Okay, 0Z, 18Z. 0Z, 18Z. So take your luck. Good luck with that, boys. You can see also the more shifts here. This was the 0Z global models from Saturday morning. You can see that again. We talked about the big shift here. I showed this earlier. I just wanted to refresh your memory. And now here's the change. This is the 12Z today. Everything is shifted to the west. Everything. Now, some of the models are still curving it at the last minute. They curve it, get up to here, and they curve it. That's still possible. But this is not going to happen. Here, yes. This, no. Okay, and this here is also the European ensembles. And look at them, how much further west they are. Again, you're getting some runs out here, but look at all this threat here. It's a possibility. That's all I'm saying. Okay, summary. The west shift is real in all the models. That's a fact. If Florence survives to September 7th, the threat increases. Threat, risk, not certainty, threat. There's a difference. Okay? If you don't know what the difference is, please do not vote and ask your mommy or daddy. This still could be a near miss. It could pass off the coast between the East Coast and Bermuda. It could go by the coastal waters. Or it can make landfall. All different sorts of possibilities here. If you or any forecaster is only looking at the tropics, you are already behind this and losing. WxRisk has been talking. I've been talking about this massive eastern U.S. Western Atlantic ridge since August 22nd, lasting through September 15th. Helene is also likely to develop next week in the far eastern Atlantic Ocean. Now, this is number 7. You can see here, this is a little system here. This was probably would have developed if it had stayed out in the Atlantic with some more. This here is number 7. Very nice. It's definitely going to develop, as you can see. You can see even more. And the problem is, of course, this is the Bahamas. It's very close to the Cuban landmass. You can see right in here. Okay, and this here's Andros Island, the big one here, and it's has to go through the Florida Straits. Now the water temperatures are pretty warm, so it's probably going to develop. I'd be surprised if it didn't. You can see the really warm temperatures in the Gulf. The problem is it's also going to go straight towards New Orleans. It doesn't linger out here. It doesn't linger out here. It goes like this, and you'll see it on all the models, and I think that's correct. Here you go. So yeah, it's 48 hours of development, maybe 60 hours. I suppose it can become a Category 1 hurricane, maybe. I'd be surprised if it did that, but maybe. It's really close to some land masses as well. All right, this was the satellite picture. Remember, I showed you this one from a couple days ago. This is the new one right here. That was old. This is the new one. So this here is Florence. Highlights, you can see it. Oops. This is Florence right here. Boom. There's the next one. Boom. And there's a couple more in here as well. So there are other systems coming down the pike. And obviously what happens is the models develop it. This is today, this European this afternoon, 120 hours. Again, you can see that it does weaken Florence, really weak here at 120 hours, September 7th. So if it survives, you have to watch out. That's the weak point right there. There's another system here, and then this here is Helene. And what happens is, of course, it begins to intensify. Now we get to Florence bombing out on September 11th, approaching the East Coast, and there's Helene. Also kicking some butt in the middle of the tropical Atlantic Ocean. So that's my video. That's my presentation. We'll see what happens here. A lot to talk about this week coming up. This is meteorologist DT from WxRisk. I'll talk to you soon.